All right, so let's take a look at this problem that we have in lecture 6b, where we have a cell with this reaction where we have iron plus copper 2 plus going to iron 2 plus metallic copper. And we're asked to determine quite a few things: electron flow, the anode and the cathode, the plus minus sign of the electrodes, the site of reduction, site of oxidation, and the movement of the salt bridge ions. And one of the first things that we want to do here is to draw out our cell. So let's go ahead and do that. So we're just going to put our couple of beakers here. We'll add a couple solutions. We'll put in a copper solution that's blue, because copper tends to be blue. We'll put in an iron solution that's yellow, because those, well, actually they tend to be green, but if it's 2 plus, it tends to be green. 3 plus tends to be yellow, but that's all right. We'll make our copper electrode red, because red's just kind of fun. So that's my copper metal there. And we'll make our iron, we'll make it gray. It's a good iron color. So there's our iron electrode. We'll attach it, our electrode to the green wire. Got a little voltmeter in there. It's not going to really matter for this exercise. And we want to put in our salt bridge. Let's make a red salt bridge. Why not? Be a nice bright color there. And we've got our little salt plugs there to let the solution move in and out. We're going to make this a potassium nitrate salt bridge solution. That's fairly common, since the potassium and the nitrate don't react with very much. All right, so let's take a look and see what we can determine from our reaction and from our drawn cell here. So if we look at the reaction, we see that we've got iron turning into iron 2 plus. And in order to do that, the iron must lose 2 electrons, and so that means that the iron is being oxidized. So that means that I have electrons coming out of the iron and flowing to the copper. Okay, so that means that my iron is the site of oxidation and copper is the site of reduction. Since iron is the site of oxidation, that means that it is the anode, and that means that copper must be the cathode. And since the anode here has a minus, then the cathode must be a plus. So we've already knocked out a lot of those things. We've looked at our electron flow, our anode cathode, our plus minus sign, and our site of reduction and oxidation. And the last thing that we have on our list that we need to determine is the salt bridge ions. And so for the salt bridge ions, we need to examine what is happening at each electrode. So here in the copper side, that's our site of reduction. So what we really have happening is I have copper 2 plus ions reacting with a couple of electrons turning into copper metal. And so I'm losing positive charge out of the solution and it's being deposited as copper metal. And so since I'm losing positive charge out of the solution, the salt bridge is going to respond by putting positive charge back into that solution. So potassium ions are the positive charge for the salt bridge, and so potassium ions are going to be flowing into the copper solution. On the other side here with the iron, I have iron ions being popped off from the electrode into solution. And so because we have iron going to iron 2 plus 2 electrons, that's my oxidation reaction there. So I'm gaining positive charge into the solution as a result of that oxidation half reaction. And so to keep that solution neutral, the salt bridge has to dump in negative charge, and so that comes from the nitrate ions. And so that's the direction of ion flow within the salt bridge. And that's everything that we need to determine for this particular problem. So if there's anything in there that you don't understand, please let me know.